Okay, one other area I'd like to talk about on limits is dealing with limits as the function goes either up or down to positive or negative infinity. So let's jump on it and take a look at this graph here. So right now I have a graph of a rational function y equals 1 over the quantity x minus 4 squared. Notice, as I'm approaching from the right-hand side of x equals 4, my function goes up and up forever. As I approach from the left-hand side of x equals 4, my function goes up and up forever. So I could say this limit is approaching positive infinity. Now I could make it approach negative infinity just by changing the sign. Now as I approach from the left of 4, it's going to negative infinity. As I approach from the right of 4, it's going to negative infinity. That's not the only thing I can do. We have functions that, let's take a look at this. Now it's just the rational function y equals 1 over the quantity x minus 4. Now, as I approach from the left, I'm going to negative infinity. As I approach from the right, I'm going to positive infinity. Technically, we would say the limit does not exist as x approaches 4 because I'm going in two different directions. Left side's going to negative infinity, right side's going to positive infinity. But one thing all of these had in common was a vertical asymptote, which you've been studying since intermediate algebra. So that's that part of the function that's not included. X can never equal 4 because you can't divide by 4. 4 minus 4 is 0. It's not defined. So the function is not defined at x equals 4. It's not in the domain. There's a vertical line, and if I was just to graph that, there is my vertical asymptote. What's very important about this asymptote is that it's not part of the function. It never touches the function. The function gets closer and closer to it as x goes to 4 because this vertical line goes to negative infinity here, positive infinity in this direction. But my function never crosses it. It just approaches it. So there's a vertical line. Now, so what I'd like to talk about now is the definition from limits of a vertical line. Okay. The vertical line x equals a is called the vertical asymptote of the curve y equals f of x if at least one of the following statements is true. This looks a little overwhelming at first, and it's not really necessary to memorize every single situation. All you have to understand is it has to be approaching positive or negative infinity from either one side or the other, and that's possible to do it from both sides. So let's look at some examples of vertical asymptotes using these definitions. Okay, let's look at part A. Right? We have a question is, what is the limit or where is the function a going as x approaches negative 3? So here's negative 3. As I approach from the left, as I approach from the right, this is both going to positive infinity. Okay, part B. Let's look at as x approaches 2. Here's the x value, 2. As I approach from, in this case, the left, here's the left, I'm going to negative infinity. As I approach from the right, that's this question, so on the right of 2, I'm going up to positive infinity. And last but not least, what is the limit of a of x as x approaches negative 1? Well, let's make sure it exists. So it has to be the same on the left as it is on the right. So on the left, as I go to negative 1, and this is where we find the x value, negative 1. So as I go to the left, it's going down to negative infinity. On the right, it's going down to negative infinity. So both the left and right are negative infinity. Now I'm just going to erase all this off my graph. I'm going to zoom in on it. And basically, what I said before is you don't have to memorize all those pieces. If I have a limit going to infinity, either from both directions, which I do at x equals negative 3, both directions at x equals negative 1, or if I'm going from the left-hand side to negative infinity, or the right-hand side to positive infinity, all of those meet the definition of my vertical lines. So I have 3 vertical lines. First one, x equals negative 3. Second one, x equals negative 1. And the third one, x equals 2. So that's how you find the equations of the vertical line, and that's how they're defined.